lines. Y'all ready? Yeah. So, our first theorem, 3-8. This is all written for you. All you gotta do is look and understand. Theorem 3-8 says the transitive property of parallel lines. It says if A is parallel to B, and if B is parallel to C, then A and C are parallel. Does that make sense to you? So you see this giant red box right here? What do you think is hiding under that red box?
Answers.
That's my description of what this property says. I would like for you to write your description of what this property says. Ready, set, go. In your notes, write down in your words what this means to you. It can be short, it can be long, it can be descriptive, it can be brief. Write down what this means to you in your notes. What do you think? Are you confused? Is it such an easy definition you don't know what to write?
I was gonna give it a shot, but you know.
Go ahead, bro. See me here what you got.
Oh, I was just gonna do it's maybe a little AB, if AB is parallel, if A is parallel to B, then B is parallel to C. Why isn't A parallel to C? They're the same.
It is. Perfect. Write it down. Just write something down. You want to see what mine says? Maybe we kind of like journey through this struggle bus together. Here's what mine says. If multiple lines are parallel, then they are all parallel to each other. That's just Baker talk versus book talk? What do you like better, the blue one or the black one? Well, write it down. If you like the blue one better, write it down. That is just your description. If multiple lines are parallel, then they're all parallel to each other. So this is explicitly the transitive property because if it's repeated, then it's deleted. You see how B is repeated? So if I repeat it, I delete it, and it says A is parallel to C. That is what the transitive property says. What if I drew line X? What can you say about line X and line B? They are parallel. What can you say about line X and line C? They are parallel, the transitive property of parallel lines. All right, the next one is an unnamed property. It's just theorem 3-9. We can't name it. Whew, this one's tough, all right? This stuff is important, but it doesn't really add to the definition, so I'm going to delete it for a second. If A is perpendicular to D, so if the red line is perpendicular to the blue line, and the green line is perpendicular to the blue line, then A and B are parallel. So it says if red is perpendicular to blue and green is perpendicular to blue, then red and green are parallel. Yes, sir. It's because of those right angles. Perfect. So I need y'all to kind of understand what's going on there. So this one says if you have one line perpendicular to the blue line and another line perpendicular to the blue line, and those two lines are parallel. So try it. Try student talk down here in the red box. Write what that means to you in student talk. It does say that they all have to be in the same plane, so they all must be on the board. Alright, so Eli is going to be the pink line. Grab it. So Eli has the pink line. He's going to hold it up so everybody can see it. Now, if the blue line is perpendicular to the pink line, right? And the green line is perpendicular to the pink line. Take the pink line away. What can you say about the green line and the blue line, or the blue and green lines? Parallel. Now hold it up again. What about this? Is blue and pink perpendicular? Are blue and pink perpendicular? Yes. Take the pink line away. Are these parallel? No, these are skew because they're in different planes. They all have to be in the same plane. Alright? How do you feel about that one? So Baker Talk says, if multiple lines are perpendicular to the same line, then those lines are parallel to each other. That's what I said. You can write it if you like it. If you don't like it, you can leave it alone. One more and we'll be done with writing. And it's just demonstration of knowledge. Yeah. It's going to be a good Monday. Right? Good Monday?
It's Tuesday.
Thank you. Today is Tuesday. Coming back for you. You're still my demonstrator. All right, the last theorem. You ready? I'm not ready. Remember that T word, transversal? Ugh, there it comes again, right? The perpendicular transversal theorem. It says if A is parallel to B and A is parallel to C and A is perpendicular to D, then B is perpendicular to D and C is perpendicular to D. Whoa, whoa, gross, right? So here's what it says. Hold me up a line. Can you hold it up higher, higher, higher? If pink and green are parallel and blue is perpendicular to pink, what do you think about blue and green? They're perpendicular. So if I have multiple parallel lines and the blue line is perpendicular to one of those lines, it is perpendicular to all of those lines. Does that make sense? So right now I have A is parallel to B and A is parallel to C. That is the transitive property of parallel lines. All three of these lines are parallel. And because this line right here, D, is perpendicular to A, it is also perpendicular to every other line. Does that kind of make sense? It's confusing though, right? That one's kind of nasty. I wrote something. It's not great, but it does the job. If multiple lines are parallel and one line is perpendicular, it's also perpendicular to all the parallel lines. That's probably not any better than the book definition, is it? No. And because I'm your favorite teacher and this is your favorite class, I've sprinkled some homework questions into the notes today. That way I make sure that they get done. Otherwise, I give them to you and they just kind of get skipped. So you'll have a total of 7 questions today for homework. Not bad. Okay. Here's one of them. We're going to skip this. The error analysis question. So skip to the box. It says, a student says that according to Theorem 3-9, that AB, let's call AB the red line, and BC, we'll call that the blue line, must be parallel because they are both perpendicular to BF. The red line is perpendicular to the green line. The blue line is perpendicular to the green line. So by definition, they must be parallel. True or false?
False.
But why false?
They're on different planes.
Because they're on different planes. Because they're on different planes. Good job. That is a great example of what you'll be expected to do today in homework. Does this seem impossible? Good. All right, here we go. Holy Jesus. I love this question because it's really confusing. This is also on your homework. I know we're skipping around. Get over it. It says the following statements describe a set of railroad tracks. Does everybody know what a railroad track is? Yes? Okay. Based on the statement, based only on the statement, make a conclusion about the rails or the railroad ties. Two vocabulary words there, rails and ties. Let's discuss that for a second. What are the rails of a railroad track? The what? The metal pieces, right? So, the rails are what the train rides on, correct? That's the rails. What are the railroad ties? The wood that ties the rails together. That's where that name came from. It ties the rails together. So, we're going to be looking at something like this and making justifications. We're going to look at number 13 specifically. The railroad ties are perpendicular to one rail. So I have a rail, and I have multiple ties that are perpendicular to one rail. What sort of conclusion can I draw from that?
Every tie is perpendicular.
That's what it says. It says every tie is perpendicular to the rail. Can I make some sort of conclusion about the ties specifically? Yes, sir, Fletcher.
Not they're all parallel.
All the ties are parallel. Does that make sense? That is like Theorem 3-8, maybe, 3-9, where it says if I have multiple things that are perpendicular to one line, all those multiple things are parallel to each other. All right, number 14 says the rails are parallel. One railroad tie is perpendicular to one rail. What sort of conclusion can you draw from that? What do you see? What do you know? What do you know about the rails? That's what the problem says. What do you know about one tie and one rail? Perpendicular. That's what the problem says. What do you know about that one tie and the other rail? Can I say that this is perpendicular? Yes. Yes. Because this railroad tie and this rail are perpendicular, I can justify that this railroad tie and this rail are perpendicular. Nice. Oh, yes. How many of you guys would not even read this?
I already read it.
Good. Most of you guys get to a paragraph and you're like, nope, too much reading. This is one of the easiest problems you'll ever do in math. But it's confusing because it's a long paragraph and there's a bunch of random names. It says, Apple Road is perpendicular to Blueberry Lane. Blueberry Lane is parallel to Cornflower Drive. Cornflower Drive is perpendicular to Daffodil Lane. Daffodil Lane is parallel to Evergreen Drive. Draw a diagram that explains how each street is related to every other street. what can you conclude about Apple Road and Evergreen Road? Yes, sir.
That Apple Road would be the one like this, and then since Blueberry Lane is connected to it, and other ones are connected to it,
Okay.
Blueberry Lane would be parallel to every other school.
So he said Apple and Evergreen are parallel. Or he could say Apple and Evergreen are perpendicular. Those are the only two answers you can give. They are parallel or they are perpendicular. You must draw it to figure it out. So, Mr. Ray, because you helped, let's draw it together. You want Apple to go up and down or left and right? Okay, I'm going to draw Apple green because apples are green. You know what? I'm going to do red because Evergreen is green. Apple Road, red. Got it. Now, it says Blueberry is perpendicular. Does that go left and right or up and down? Okay. Blueberry. Is everything true so far? Apple is perpendicular to Blueberry. Correct. Now it says Blueberry is parallel to Cornflower. So blue and Cornflower should be, which way does Cornflower go? Left and right? Okay. I got Cornflower right here. Is it still true? Blueberry and Cornflower are parallel. Alright? Daffodil is parallel, Cornflower is perpendicular to Daffodil. So does Daffodil go up and down or left and right? Daffodil goes up and down. Daffodil is perpendicular to Cornflower. Correct. And it says Daffodil is parallel to Evergreen. Does Evergreen go up and down or left and right?
Wait, no, up and down.
Up and down. What do you know about the red line and the green line? They're parallel. So you can say Apple and Evergreen are parallel. That's confusing as a lot of words, but does the whole concept make sense? I'm not a huge fan of the paragraph because you will see stuff like this on your assignment where it's just a straight sentence of mathematics. So I want you guys to pick two. We're going to do two together. Who wants to give it a shot? Pick two, pick two, pick two. All right, 19 and 20. So Keegan, we'll do 19 first. I'm just going to do this in straight pencil. Is that okay with you? A is perpendicular to B. Which way do you want A to go? He gestures this way. Okay? It says A and B are perpendicular. Which way does B go? Perpendicular. So B goes this way. B and C are parallel. Which way does C go? This way. He gestures this way. C and D are parallel. Which way does D go? Same way. What do you know about A and D? Look at A. Look at D. Are they parallel or perpendicular? A is perpendicular to D. That's your answer. Does that seem like rocket science to you guys? All right, you can just make some small mistakes by drawing them incorrectly. All right, so he said number 20 as well, right? We said 20. So we'll draw number 20 over here. Struggle bus. A and B are parallel. Is that an 11 or a T? 11. B and C are perpendicular. Is that an 11 or a T? A T. C and D are perpendicular. Is that an 11 or a T? A T. What do you know about A and D? A is parallel to D. Nailed it. How do you feel about that? Good?